Assalamu alaikum wa rahmatullahi wa barakatuh. In this lesson, we are going to talk about a special method of finding limit, which is called squeezing or sandwich theorem. First, let us talk about the definition of this theorem. Let us first talk about the definition of this squeezing or sandwich theorem. If we have a function g of x, and this function is between two other functions, but these two other functions, h and f, somewhere near a point or where the limit of these two functions are both equal, such as the limit for h is L and also f is L. In this case, we conclude that also f should equal to L. So this is the meaning of this sandwich theorem. So in a proper way, we say if the limit of the left end equals the limit of the right end, so of course the limit in the middle should equal L. To make it clear, if I say if the limit of, for example, f of x is 3, if we know that this limit is 3, and limit for h of x, which is the right side or right hand, also 3. So of course any limit in between should equal also 3. Should equal also 3. That means for some points, limit of h of x or g of x here, g of x should also equal 3. So the main idea here is to find two of the same limits and make sure that they are the same and make sure that our limit is in between these two functions. Let us take this example. I want to find limit when x goes to infinity for sine x over x. First, if I replace, of course, I will get sine x. We know at the end it's either 1 or minus 1. 1 or minus 1. So that means I will not get a specific number. That means this sine x over x at x goes to infinity, it oscillates or oscillating between -1 and 1. So we cannot get the exact answer. So we need to search for another method. Squeezing method or sandwich method, it's an appropriate method here. So we need to find a function or two functions, and our question sine x over x, we need to develop our function to be in between two of the same numbers. So I need to develop this issue. So what I will do, I will start with something I know, one of the identities, which is sine x, it is between -1 and 1. This is what we know. But this is not our question, so I need to develop. So what should I do for this sine x to be our question? So I need to divide all by x. So when I divide all by x, I get here x, I get here sine x over x, and I get here x. So I will get a new identity or a new inequality that sine x over x, which is our question, between 1 over x and minus 1 over x. Now we need to make sure, are these 1 over x and minus 1 over x have the same limit? So let us take this one. We need to make sure, is this limit and this limit both are the same? If both are the same, So our limit exactly will get the same result. We know this one is 0. Why it is 0? Because we learned that if a limit of polynomial over polynomial, we follow the degree. The degree here is less than the degree of down. So the limit is 0. And the other one also is 0. So what we got now, our question now, or our limit now, is between 0 and 0. So we conclude, according to the Sandwich theorem, that our question is also 0. Now let us take one more example. If we take this example, of course, we cannot also replace, because if I replace, I will get pi over 0, and pi over 0 is undefined. And also I cannot replace this one alone and that one alone, because there is no product rule for limits. So in this case, what we do, we start with something we know, which is sine. But if the question is cosine, we start with cosine. So sine is between -1 and 1. But this is not our question. Our question has something called x squared. So I need to multiply all by x squared. When I multiply all by x squared, what I get that our question, or our limit, it's now between x squared and minus x squared. Now, if I take the limit for all sides, so I will get this limit, which is, we know it is 0, and also this limit, we know it's also 0. So we found that our question now between 0 and 0. That means our question also is 0. One more example. Since I have x cubed multiplied by sine, of course I will start with sine. So I will start with sine. What I do, I say sine, the function that I have, which is 1 over whatever the angle, always the sign between -1 and 1. Whatever the angle, the sign is in between 1 and -1. And as I said here also, this is not our question. Our question, we have x cubed multiplied by this. So I need to multiply to develop, to create our question. So in this case, this will be minus x cubed, because when I multiply, and this will give me my question, which is x cubed multiplied by sine 1 over something, and at the same time the right side also x cubed. Now if I find the limit for all sides, of course here the limit of this one, when x goes to 0, because the question that, so I get 0 here. And when I find this limit, that's what I want to find for our question. Find 1 over such that. This is what we want to find. The right side also, this limit here, if I put limit here also we will get 0. That means our question now between 0 and 0. So of course the answer will be 0. One more example. This example can be solved by two methods. The first method, if I use Sandwich theorem from the beginning. So I start with sine x as usual, because the question is sine x. I have sine x here, so I will start with sine x. And we know the identity sine x between 1 and -1. Now, this is not my question. My question has 5x plus. So we need to add 5x for all sides. for everything. So here I will get 5x. When I add it, it will be 5x minus 1. And the right side will be 5x plus 1. And in between, we have 5x plus sine x. We have 5x plus sine x. So still, I didn't get my quotient over x. So in this case, I have to divide all by x to get my quotient. So when I divide all by x, so what I get here, I still, and at the same time, I find limit, or I take limit for all sides. So when I take limit for all sides here, so I will get this limit. We know, since the polynomial of up of degree 1 and the polynomial of down also degree 1, so the degree of numerator equals the degree of denominator, so the limit will get the coefficients 5 over 1. And the right side also will be the same, 5 over 1. That means our quotient, or our limit, will equal to 5. This is using the sandwich theorem from the beginning. Sometimes you can solve this equation by a different way, which is to divide it into two quotients. If I divide it into two quotients, I will use distributed property. I divide this by that, and at the same time, I divide sine x by x. This is called distributed property. So I got now two quotients, or two limits. The first one is this one. When I simplify it, I get only a limit of 5. But the second one, it is limit of sine x over x. This we know from the first example. By using sandwich theorem, we get what? We get equals, if you remember, we get equal to 0. And limit of 5 is 5. So the answer 5 plus 0 is 5. So this is what we got by a different method. Thank you very much.